The next thing I want to talk about is solving equations in quadratic form. This is also referred to as U substitution, or it will be when you get into calculus. So in general, the appropriate substitution U transform an equation into one of the form AU squared plus BU plus C equals 0, where A doesn't equal 0, right? Because then it's still a quadratic. It has to be degree 2. So here's an example of an equation in quadratic form, right? If I can substitute U in to my original equation, I get one that's now in quadratic form. So if I have x plus 2 squared plus 3 times x plus 2 minus 4 equals 0, my U is going to be x plus 2. It's always best to look at the term on your B and see if the A term is a square of that in order to check if this is indeed an equation in quadratic form. So here I'm going to let U equal x plus 2, and we're going to substitute that in. So I have u squared plus 3u minus 4. And then I can go ahead and solve this equation normally, okay? So what are some factors of negative 4 that add up to 3? Well, that's going to be negative 1 and 4. I set each of those equal to 0. So I get u equals negative 4, and I get u equals 1. And then I can go ahead and substitute u back in. So I have x plus 2 equals 1. That's going to give me x equals negative 1. And I have x plus 2 equals negative 4. That's going to give me x equals negative 6. So like I said, you want to look for the term. You want to look primarily at the b term and what's going on with the original variable to see if the first term is a perfect square of that. Let's take a look at this example as well. I've got x plus 2x minus 3 equals 0. So what I'm going to go ahead is I'm going to say, okay, my u could be square root of x. Well, is the square root of x squared x? Yes, it is. So I'm going to use u substitution for the square root of x. So I'm going to rewrite my middle term as the square root of x squared plus 2 square root of x minus 3 equals 0. And then I can use u substitution. I get u squared plus 2u minus 3 equals 0. Factors of negative 3 that add up to 2 are 3 and negative 1. I have u plus 3 equals 0, u minus 1 equals 0. That gives me u equals negative 3, and u equals positive 1. I then go ahead and let the square root of x equal negative 3 and the square root of x equal 1. Well, square roots can never be negative, so this is not a solution. But the square root of x equals 1, that could be a solution because x would equal 1. This would be our solution. I solved that by squaring both sides. Next, we're going to talk about the absolute value function. So the absolute value function is a graph of y equals the absolute value of x. This is the most basic absolute value function. We haven't altered it by adding or subtracting any constants, either inside or outside the absolute value bars. It's important to remember that its values, when in this case, are only going to be positive, because if I take the absolute value of any negative number, that becomes a positive number. I can take the absolute value of any number that's real. So the absolute value of negative 1 would be 1, the absolute value of 0 would be 0, and so on and so forth. So it is symmetrical. It has a line of symmetry. That's the y-axis. My domain is all real numbers, but my range goes from 0 to positive infinity. When I'm solving absolute value equations, I have to keep in mind that the absolute value of my equation set equal to a constant is going to be u equals a or u equals negative a, right? Because if I had the absolute value of x equals 7, what are the two values of x I could have? Well, I could have, my solution set would be negative 7 or 7, because both of these would give me an absolute value of 7. So let's take a look at this example. I have the absolute value of 1 minus 2z plus 6 equals 9. The first thing I want to do is isolate my absolute value. So I'm going to subtract 6 from both sides. I have 1 minus 2z equals 3. I now know that if I have 1 minus 2z, that could be equal to 3, or 1 minus 2z could equal negative 3. I'm going to subtract 1 from both sides. I get negative 2z equals 2, so z in this case would be negative 1. I subtract 1 from both sides. I have negative 2z equals negative 4, so z in this case would be 2. And I need to check my solutions. So let's go ahead and check z equals 1. I have 1 minus 2 times negative 1 plus 6 equals 9. So that's 1 plus 2, the absolute value of that, plus 6 equals 9. I get 3 plus 6 equals 9, which is true. So z equals negative 1 is a solution. Let's try again. I have 1 minus 2 times 2 plus 6 equals 9. I have 1 minus 4, absolute value, plus 6 equals 9. So I have the absolute value of negative 3 plus 6 equals 9, which is 3 plus 6 equals 9, which you guessed it gives us 9 equals 9. So our solution set would be both of these values of x. My solution set is negative 1 and 2. Let's try this again. I have the absolute value of x squared plus x equals 12. I'm going to go ahead and solve this. I've got x squared plus x equals 12. And I've got x squared plus x equals negative 12. I'm going to go ahead and set both of these equal to 0. So x squared plus x minus 12 equals 0, and x squared plus x plus 12 equals 0. Let's look at this equation on the left. I have that I'm going to factor this. I have x, the factors of negative 12 that add up to 1 are x equals, our negative 12 is 4 times negative 3. So I've got x plus 4 and x minus 3 equals 0. I'm going to set both these equal to 0. X plus 4 equals 0, x minus 3 equals 0. So I get x equals 4 and x equals negative 4 and x equals positive 3. Now, if I try and factor x squared plus x plus 12 equals 0, that's not going to happen. So I'm going to have to use the quadratic formula. Or I could complete the square, but I don't want to. So I have x equals, I put my radical too soon. X equals negative 1, which is negative b, plus or minus the square root of b squared minus 4 times a times c all over 2a. Now I hope you can see that under my radical symbol I'm going to have 1 minus 48. That's going to be negative 47 over 2. Well, this is going to be a complex number. This is not a real solution. And right now we're only working with the real number line. So this is going to be my solution set because we cannot have complex solutions at the moment. So no complex solutions. Next, let's go ahead and look at these two. We want to check all solved x values are solutions in the end. So I've got x to the fourth minus 4x squared equals 0. I'm going to pull out the greatest common factor. That gives me x squared minus times x squared minus 1 equals 0. I could then, minus 4. I can then go ahead and factor this binomial right here. I've got x squared times x minus 2 times x plus 2, and the reason I knew this was going to factor because it's a difference of perfect squares. So I'm going to set each of my factors equal to 0. So I get x equals 0, and that appears twice. That means it has a multiplicity of 2. But remember, we only want to write it once in our solution set, if it's in our solution. I then have x minus 2 equals 0, so I get x equals 2, and x plus 2 equals 0, so I get x equals negative 2. And I'm going to check these solutions into my original equation. So I can see that if I plugged in 0, I'd get 0 to the 4th equals 4 times 0 squared, which you guessed it is 0 equals 0. So my solution set includes 0. I then want to try a positive 2. I've got 2 to the 4th equals 4 times 2 squared. So 2 to the 4th is 8 times 2, which is 16, equals 4 times 4, which is also 16. So good job. And the same is going to hold true for negative 2. So all three of these are in my solution set, and typically we want to write these from smallest to largest. This last equation I'm going to factor by grouping. The greatest common factor of x cubed and x squared is x squared. The greatest common factor of negative 4x and 4 is negative 4. Remember, we don't want negative leading coefficients. I collect my greatest common factors and my remaining binomial. I already know that x minus 4 is going to factor to x plus 2 times x minus 2 times x minus 1 equals 0. I set each of these equal to 0. I get x equals 2, negative 2, x equals 2, and x equals 1. And I'm going to go ahead and let you know that all of these are in our solution set, but you should always check your work.